Hello everyone, I'm Dr. Janabi Chakrabarti, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I'm going to discuss the Newton's backward interpolation formula. Let us first see what is Newton's backward interpolation formula, how it is defined, and when we can use this formula. Let y equal to f of x be a function which takes the values y0, y1 and so on yn corresponding to the equally spaced values x0, x0 plus h, x0 plus 2h and so on x0 plus nh of x. Here h is interval of differencing. Now to evaluate the function f of x or to estimate f of x for x equal to xn plus ph, where p is any real number, the Newton's backward interpolation formula is given by this one. So this is yx is equal to yn plus p into backward difference on yn plus p into p plus 1 by 2 factorial, second backward difference on yn plus p into p plus 1 into p plus 2 by 3 factorial, third backward difference of yn plus p into p plus 1, p plus 2 into p plus 3 by 4 factorial into fourth backward difference on yn and so on plus p into p plus 1, p plus 2 and so on p plus n minus 1 by n factorial into nth backward difference on yn, and here p is x minus xn by h. This Newton's backward interpolation formula is used for interpolating the values of y near the end of the tabulated value and extrapolating the values of y just right to the end of the table. Let us understand this statement with an example. Let y equal to f of x and let this is the tabulated form for x and y values x0, x1, x2 and so on xn. What are the y values? y0, y1, y2 and so on yn. To evaluate f of x for x equal to xn plus ph, where p is any real number. The Newton's backward interpolation formula is given by yx is equal to yn plus p into first backward difference of yn plus p into p plus 1 by 2 factorial, second backward difference on yn plus so on plus p into p plus 1, p plus 2 and so on p plus n minus 1 by n factorial into nth backward difference of yn. So this is the Newton's backward interpolation formula. Now let us take one example. So this is what is given to you. These are x values, these are y values. So x values are given to you 3, 4, 5 and 6. And y values are 10, 20, 30, 35. Now first of all you look at these points. These are all equally spaced. Okay. If these are equally spaced, then only we can use Newton's backward interpolation formula. Now if you are asked to estimate y for x equal to 5.5. Look, this x equal to 5.5 lies in between 5 and 6. So this is the end of the table, right? When you need to estimate y for such values which lie at the end of the table, you can use Newton's backward interpolation formula. Also, if you need to estimate y for x equal to 6.5. Now look, this x equal to 6.5 doesn't lie in this range. It lies outside this range. But this is just right to the end of the table. So you can use the Newton's backward interpolation formula. Now let us solve few problems using this Newton's backward interpolation formula. Now let us solve this first problem where it is given that 23.6 is the sixth term and one table is given. First you check that whether these x values are equispaced or not. These x values are equispaced, right? Because 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1 and so on. Now next what you need to find? You need to find the 10th term of this series. As you can see, 10th term doesn't lie in this range. It is just right to the end of the table. So you can definitely use the Newton's backward interpolation formula. To use Newton's backward interpolation formula, first of all, we need to form the backward difference table. The backward difference table is given by, these are x values, these are y values. X values are given as 3, 4, 5, 6, 7, 8, 9. And y values are 4.8, 8.4, 14.5, 23.6, 36.2, 52.8, 73.9. Now we need to write the first backward difference. So the first backward differences are given by 8.4 minus 4.8, it is 3.6. 14.5 minus 8.4, it will be 6.1. 23.6 minus 14.5, it will be 9.1. 23.6 minus 36.2, it will be 12.6. 52.8 minus 36.2, it will be 16.6. 73.9 minus 52.8, this will be 21.1. Now the second backward differences. The second backward differences are given by 6.1 minus 3.6. So it will be 2.5. 9.1 minus 6.1, it will be 3. 12.6 minus 9.1, it will be 3.5. 16.6 minus 12.6, it will be 4. And 21.1 minus 16.6, it will be 4.5. Next is third backward difference. 3 minus 2.5, it will be 0.5. 3.5 minus 3, it will be 0.5. 4 minus 3.5, it will be also 0.5. And 4.5 minus 4, that will be also 0.5. Next is fourth backward difference. 0.5 minus 0.5, it is 0. This will also be 0 and this will also be 0. Next is fifth backward difference. This is also 0. This will be 0. This will be 0. And sixth backward difference will also be 0. So this is how we form the backward difference table. Now in the formula of backward difference, now in the Newton's backward interpolation formula, which are the terms are required? So look at this table. This is xn, this is yn, right? And this is first backward difference on yn. This will be second backward difference on yn. This is the second, this is the third backward difference on yn. And fourth backward difference, fifth backward difference, sixth backward difference on yn, all are 0. Now, therefore here, xn is 9, yn is 73.9, h is 1, and what you need to find? X equal to 10, x equal to 10. Therefore, what will be the p? P is x minus xn by h, x minus xn by h. So what is x? 10 minus 9 by 1. This is 1. Now by Newton's backward interpolation formula, we have yx is equal to yn plus p into first backward difference on yn plus p into p plus 1 by 2 factorial second backward difference on yn plus p into p plus 1 p plus 2 by 3 factorial third backward difference on yn. Now we can substitute the values x as 10, yn then p and this first backward difference, second backward difference and third backward difference. So we will get y10 is equal to yn is 73.9 plus what is p? P is 1 into first backward difference, that is 21.1 plus 1 into 1 plus 1 by 2 factorial into second backward difference on yn, that is 4.5 plus p is 1, 1 plus 1, 1 plus 2 by 3 factorial and third backward difference is 0.5. Now if you compute this value, you will get y10 is equal to 100. This is how you can find the 10th term of the series using Newton's backward interpolation formula. Now let us do another problem where one table is given to you and you need to find the value of y at x equal to 35. Now first of all, look at this table. These x values are equally spaced, right? The difference is 10. Also, this x equal to 35, it belongs in between 30 and 40. So as it is at the end of the table, we can use the Newton's backward interpolation formula. So for that, we need to form the backward difference table first. The backward difference table these are x values, these are y values. X values are 0, 10, 20, 30 and 40. And y values are 7, 18, 32, 51, 87. First of all, we need to find the first backward difference. That will be first backward difference of y. So 18 minus 7, it will give you 11. 32 minus 18, this is 14. 51 minus 32, this is 19. And 87 minus 51, this will be 36. Next, we need to find the second backward difference. 14 minus 11 is 3. 19 minus 14 is 5. And 36 minus 9 is 17. Next, third backward difference. So it will be 2, 5 minus 3 and 17 minus 5 is 12. Next is fourth backward difference. It is 10. So this is how you need to form the backward difference table. Now here, what are the terms that are required in the Newton's backward interpolation formula? So look at this. This is xn. This is yn. This is first backward difference on yn. This is second backward difference on yn. This is third backward difference on yn. And this is fourth backward difference on yn. So these are the points which are required in the formula. Here xn is equal to 40, yn is equal to 87, h is 10 and x is 35. Therefore, P will be x minus xn by h. X is 35 minus 40 by 10 minus 5 by 10. This is minus 0.5. And also first backward difference on yn is 36. Second backward difference on yn is 17. Third backward difference on yn is 12. And fourth backward difference on yn is 10. Now we can use the Newton's backward interpolation formula. Therefore, by Newton's backward interpolation formula, we have y of x is equal to yn plus p into first backward difference on yn plus p into p plus 1 by 2 factorial second forward difference on yn plus p into p plus 1 p plus 2 by 3 factorial into third backward difference on yn plus p into p plus 1 p plus 2 p plus 3 by 4 factorial into fourth backward difference on yn. Now, if we substitute the values, we will get y35 is equal to yn is 87 plus p is minus 0.5 into first backward difference, that is 36, plus minus 0.5 plus 1 by 2 factorial into, this is 17, plus minus 0.5 plus 1 minus 0.5 plus 2 by 3 factorial into third backward difference, this is 12, plus minus 0.5 plus 1 minus 0.5 plus 2 minus 0.5 plus 3 by 4 factorial into, this is 10. Okay, if you compute this value in calculator, it will give you 65.7343. So this is how we can find this value. So this is how we need to use the Newton's backward interpolation formula to estimate the yx for any given value of x. Thank you.